Hello fellow problem solvers, so they're going to be doing this introduction to geometry, some techniques. Namely, here we're going to be looking at the midline in a triangle. So we have ABC are some points in a plane which are not collinear. Let's make them like this. ABC. I'm going to connect them with lines. And D and E are the midpoints of AB and AC respectively. So this is this midpoint. E is this midpoint right here. And we need to prove that DE is parallel to BC, and that it is half the length of BC. Okay, so how do we do this? Well, in this situation, we need to look at what would happen if DE was parallel to BC. And here's where you need to gain some information. You need to put in, like, say, what are the different angles in the triangle. So we call this angle, let's say, beta, call this angle gamma, call this one alpha. Now, if this is common in geometry, sometimes you solve the problem forwards, you see like, oh, what is it that I have? What is it that I have? And then you get to a solution. But sometimes you solve the problem backwards. You say, if the problem statement was true, what would I have? What would I have? And then you try to connect what you have and what you would have. Or sometimes you try to connect what you would have, like if the problem statement was true, you're trying to prove that thing instead of the problem statement itself. So that is sort of what we're going to be doing here. Now, if this was parallel to this, we would have that this angle was beta and this angle was gamma. Okay? And then what would we have? The answer is we would have that ADE and ABC are similar triangles. And not only that, we would have that your factor of similarity is 2 or half, depending on how you look at it. And so maybe the idea is, like, we would have just from the angles that they are the same, they're similar, but maybe there's a different thing. We don't have the angles just now. Maybe we can use another thing to show that these are similar. So what can we use here? And the answer is we can use, well, we can't use the angle here. We can't use the side condition. We only have one angle, namely alpha, DAE. Let's write that down. DAE is equal to the angle BAC. And so, given this is the only angle we have, we need to have this, ratio between the sides. And we need to have that AD over AB. What is this equal to? And the answer is, if this is x, and this is x over x plus x, so this is equal to 1 over 2, which is also equal to AE over AC. And from here, we get by the side angle side similarity condition, we have that the triangle DAE is similar to the triangle BAC. And now what do we have from the similarity? Well, the answer is, from the similarity, we now get that the angle ADE is equal to the angle ABC. So we get that this angle is in fact equal to beta, this angle. We also get that the angle AED is equal to the angle ACB, which means that this one's gamma equal to this one. And also, mind you, now because this one's beta, that means this is 180 minus beta. And now we have that, given the sum of these two angles is 180, that DE is parallel to BC. However, we still need to prove that it's twice that BC is twice the length of DE. And how do we do that? Well, also from the similarity, we have that AD over AB is equal to, in fact, what? And the answer is, it's equal to DE over BC. And given this was 1 over 2, if we take this and this, we will get that 2 times DE is equal to BC, which is what we need to prove. This finishes up our problem, and as always, thanks for problem solving.